This example shows you how to calculate the work that friction does while an object is moving. We have a car with a mass of 1,234 grams. It moves for a total distance of 61 meters, and the coefficient of kinetic friction between the car and the road is 0.45. And the question is, how much work does friction do during this trip? Now remember, we can calculate the work done with equation 8.1, but to use that equation, we need to know the force that is applied. In order to figure that out, we're going to have to go back and use our old friend, the equation for frictional force. Frictional force is mu times the normal force. Now remember what the normal force is. The car is sitting on a level road. The weight of the car pushes straight down on the road, and the road pushes back with a normal force that is equal to that weight. So the normal force is simply the mass of the car times g. So the frictional force is mu, 0.45, times the mass of the car, 1,234 kilograms, times g, 9.8 meters per second squared. When we work that out, we find that the frictional force is 5.4 times 10 to the 3 newtons. Now that we know the frictional force, we can calculate the work done by friction. Equation 8.1 tells us that work is the parallel component of the force times the displacement. Now think about friction. Friction directly opposes the motion. So the force of friction is oriented directly against the motion. So the entire force of friction is parallel to the motion. So we can use 5.4 times 10 to the 3 newtons as the parallel component of the force. So work is 5.4 times 10 to the 3 newtons times the displacement, 61 meters. And when I work that out, I get 3.3 times 10 to the 5th newton meters, which is the same as 3.3 times 10 to the 5th joules. So friction does 330,000 joules worth of work during the car's skid. That's a lot of work. Now the main point of this example is to show you how to calculate the work due to friction. First calculate the frictional force like we've always done, then multiply by the distance. That gives you the work due to friction. We're going to use this in the upcoming problems that we're going to analyze.